This is section 5.7, inverse trigonometric functions. We're going to begin with the inverse sine function. Let's recall that in order for a function to have an inverse, it must be a one-to-one function. And as you can see, this fails. The graph of y equal to sine of x fails the horizontal line test. Therefore, it's not one-to-one. So an inverse doesn't exist for y equal to the sine of x, as you can see over to the right, because this graph is not a function. It fails the vertical line test, therefore not a function. So we have to restrict the domain of y equal to sine of x, and we will restrict it between negative pi over 2 and pi over 2. So as you can see, we have this beautiful graph now that is one-to-one. Therefore, an inverse function exists, and we do have a function. Now, the important thing to remember is that the sine of x is restricted, has a restricted domain between negative pi over 2 and pi over 2 in order for the sine function to exist. Okay? So we will name this sine function and note it by either saying sine inverse or arc sine. You'll see both of those for the inverse sine. Also, y equal to the sine inverse of x is the same, interchanging the x and the y values as the sine of y equals x. Okay? And so we now can see that the arc sine of x is the same thing. Again, here are the restrictions on this angle that we are looking for, okay? When you have y equals the sine inverse of x, we are looking for an angle y between negative pi over 2 and pi over 2. And it's a one and only unique angle that we are looking for, okay? And we will draw a little graph each time. Okay, let's just jump right into the first example. We have the sine inverse of negative 1/2. We'll set that equal to y, and then we will say that the sine of y is equal to negative 1/2. Now, where is the sine negative? The sine is negative in quadrant 3 and quadrant 4. However, we have a restriction, negative pi over 2 to pi over 2. Those are the only angles we can give, the one and only angle that satisfies this inverse trig value, and it will be quadrant 4. So what will that angle be? Yes, that angle will be the opposite of pi over 6 because the sine of negative pi over 6 is negative 1/2 when we have that angle, okay? Okay, let's go ahead and go to number 2. We'll write this as the arc sine of root 3 over 2 is equal to y, so we can say that the sine of y is root 3 over 2. Our sine is positive in quadrant 1 and 2. And we are restricted again, and I won't write this every time, between negative pi over 2 and pi over 2. Those are the only angles we can give for this one and only angle that we need to find. And of course, we will be in quadrant 1. And so y must be equal to pi over 3. Yes, because the sine of pi over 3 is root 3 over 2. Okay? Okay, let's go to number 3, sine inverse of 5 pi over 4. We set that equal to y. And so we know that the sine of y is equal to 5 pi over 4. Now, the sine or the cosine of any angle must be between negative 1 and 1. So as you can see, 5 pi over 4 is greater than 1. So this is not a possibility, and we can say that y does not exist. Okay, taking a look now at the inverse cosine and the inverse tangent functions. As you'll notice now, we have the same restriction on the inverse tan function. We must come up with that one and only unique angle that will be between negative pi over 2 and pi over 2. And look at the restriction on the cosine, and you will need to know these. And now, as you can see, our cosine of x is 1 to 1. The inverse is a function, passes the vertical line test, and so forth, okay? So it's really, really important, but these are the key right here. This is what's very important, is this is the only range that we can come up with that angle, okay? It must be between those values, inclusive for the cosine inverse and strict inequalities for the tan. So let's jump right into an example here. We'll start with the arctan of 1. So we'll let that equal y, and so we can say that the tangent of y is equal to 1. Now, where is the tangent equal to 1? A positive 1 is in quadrant 1 and 4. And remember, our restriction for the tangent is just like the sine. So we have to come up with a value between negative pi over 2 and pi over 2. So we choose quadrant 1. And so we can say that y is equal to pi over 4. Okay? Because the sine and the cosine are equal at pi over 4. So that would make the tangent equal 1. Okay? Cosine inverse of negative 1/2. So now we can write y is equal to, the cosine of y is equal to negative 1/2. Again, where is our cosine negative? Either in quadrant 2 or quadrant 3. Now, this is the first cosine inverse we've had. And keep in mind, that we need that cosine, that angle, to be between 0 and pi. So I'll write it on this one. Here's 0 to pi. That's the only place that we can give this unique angle on that interval, and it will be here. So what do you notice here? You can see now that y would have to be 2 pi over 3. Okay, so this is 2 pi over 3. And that cosine right here would be negative 1/2. Okay, the arc cosine of root 3 over 2 is equal to y. So the cosine of y is root 3 over 2. Again, we have a positive value for cosine, or this time we have a positive value. We will be in quadrant 1 or quadrant 4. Of course, we have to choose quadrant 1 because we have to be give an angle between 0 and pi, okay? And so we will have this angle here, and we know that y is equal to pi over 6. Because the cosine of pi over 6 is equal to root 3 over 2. Okay, the tan inverse of 0 is equal to y, so the tangent of y is equal to 0. And what angle gives us the tangent of that angle equals 0, and that would be 0, because the tangent of 0 is 0. Okay, now let's go on to inverse trig functions on a calculator. Now notice what we have in this question. we are going to give these values in radians or degrees. So we could go ahead and I'm going to give them both to you, but you should be able to do both of those. So let's get our calculator up, and this is pretty easy on the calculator because you have the cosine inverse and sine inverse right there above each trig function on the calculator. So let's see what mode I'm in. I'm in radian mode now, so I'll give radians for all of these first. So I'm just going to set approximately, and I'll give radians first, okay? So we're going to have the cosine inverse, so secant cosine of 3/5. And that will be 0.9, and we'll just approximate maybe 4 decimal places, 9273. And those are radians. I'll put a little r here, and then we'll give degrees in a minute. Okay, now let's have the sine inverse of negative 0.457, and we will come up with negative 0.4746. And those will be radians, and we'll give degrees in a minute. And then we'll have the tan inverse of negative 2.09, and we get approximately negative 1.1245. Okay, and now let's switch our mode to degrees. And now we can go back, and this is kind of a neat feature of the calculator. So we're going to have the cosine inverse of 3/5, and we get 53.1 degrees. So as you can see, I'm reusing what I have already typed, but I'm in degree mode. So this would be negative 27.2 degrees. And then the tan inverse was the last one we had, and that would be 64.4, let's just say 64.4 degrees. Okay? Now, let's take a look at number 11. I'm going to keep the calculator out for this one because they've asked us again to use a calculator to approximate the degree measure. And we're going to go to 1 decimal place, and we're going to use degrees. And we're in degree mode right now. So we want to know, use a calculator to approximate the angle theta, where the sine of theta equals 3/8. And they want us to provide an angle between 90 and 180 degrees. So what will we do here? We know that this can also be written as theta equals the sine inverse of 3/8. So let's go ahead and do that in our calculator. So theta is approximately 22 degrees. Okay, so now 22.0 or 22. So now let's take a look at this quick little graph here. And the sine is positive in quadrant 1 and quadrant 2. Now, this is providing 22 degrees is not between 90 and 180 degrees. So we need to go a little bit further. So what can we do? We can take 180 degrees and subtract 22 degrees to give us that same angle here. And what we come up with is going to be 158 degrees. Okay? So now let's talk about composing trig functions. I think you'll really like this, but there are some tricky ones. So don't just jump too fast into using a pattern that we will talk about, okay? So now we're going to talk about composing, or the composition of trig functions with their inverse trig function. So what do you notice here? The sine of the sine inverse of x is equal to x. Likewise for the tangent and the cotangent. But that's only when that x value is between -1 and 1. Okay? So now we notice that the sine and the tangent and the cosine, when we take the inverse of those functions, sine, tangent, and cosine, we need to make sure that x is between -pi/2 and pi/2. So let's go ahead and see what happens when that is the case and when it might not be the case. Okay, so let's begin with number 12a, this arc sine of the sine of -pi/6. And that is actually going to be equal to -pi/6. And the reason is, since -pi/6 is between -pi/2 and pi/2. Okay, so you could almost say that these cancel each other out because we go to interchange the domain and range and then go back to the original. Okay, now let's look at B, where we have to make a slight adjustment here. So this is going to be equal to, we're going to have to rewrite this first. So let me just draw a little graph. And 7pi/6 is right here, okay? We're going to have to rewrite this because we need an angle somewhere here, in here. But of course we know it's going to have to be here, since that sign was negative, we'd have to be here, okay? So how do we rewrite this? We will now have, we can rewrite this angle as -pi/6, because we would come up with the same value for the sine. So now we would have the arc sine of the sine of -pi/6. Since -pi/6 is between -pi/2 to pi/2, we can now say that this is equal to -pi/6. So we may have to rewrite that angle, okay? Let's look at the cosine inverse of the cosine of 7pi/6. We are going to have to rewrite that also. And as you can see, if you want to take a look at these, our cosine values have to be between 0 and pi. This value right here must be between 0 and it's not, so we are going to have to rewrite. So where do we have 7pi/6? There's 6pi/6, so this would be 7pi/6. And we're going to have to rewrite that. And we need between 0 and pi, so it would be right here. Okay, and that would be 5pi/6. So now we have that this is equal to the cosine inverse of the cosine of 5pi/6, and that's just equal to 5pi/6. Okay, so checking that restriction is really important. Now, let's go ahead. All of these started with the inverse function composed with the regular function. And what do you notice about negative 1/2? Let's go ahead and write this. This is equal to, so we can have, if we have negative 1/2 as our angle, we will need to rewrite that, and we can have positive 1/2 because the cosine will be the same in quadrant 1 and quadrant 4. So negative 1/2 is not between 0 and pi. So we rewrite. So now we will have this right here. And so we can say that this is equal to the cosine inverse of the cosine of 1/2. And that's equal to 1/2. Okay, let's keep going. We're going to find the exact value in number 14 in both of these problems. So we're given that the cosine of the sine inverse of 40 over 41 needs an exact value. So what do we notice? Let's go ahead and make a little sketch here. And as you can see, we are looking for some angle theta. So we are going to say theta equals the sine inverse of 40 over 41. And so now we can go over here and draw that on our sketch here. So we have theta, that's that theta. We have 40 and we have 41. So I've just drawn a typical triangle. So how can we solve for this x? X squared plus 40 squared equals 41 squared. So we have x squared equals, I'll go ahead and square those for you, 1681 minus 1600. And we come up with x squared equals 81 and x equals 9. Okay, so now that same theta we will use. So now we can say that the cosine of theta, remember, the cosine of theta is adjacent over hypotenuse. Oops. Okay. So that is the exact value. Okay, looking at B, we have the cosine of the sine inverse of the opposite of 40 over 41. Let's go ahead and let this be theta. So what are we really trying to find? The cosine of theta. So that's really what I was doing here. And so that's what we're going to be doing here. We're looking for that exact value. Well, what can you say? You can say that theta is equal to the opposite of, is the sine inverse of negative 40 over 41. Okay, so let's go ahead and draw, theta is equal to that, yes. So we can draw our sketch here, and we'll go ahead and just make a little triangle. So we have negative 40, we have the hypotenuse is 41. Keep in mind the sine is the opposite over the hypotenuse. And that's our theta, okay? So same over on the other side. We're going to have this equal 9 since 9 squared plus 40 squared equals 41 squared, okay? And that's from the previous problem, part A, okay? So now, what can we say? We can now say that the cosine of theta, which is adjacent over hypotenuse, is 9 over 41. Okay. Okay, now let's write the tan of the arc sine of 2 over x for the absolute value of x is greater than 2 as an algebraic expression. So actually, we're going to do the same thing we just did. We are going to be looking for, they want us to find or write the tangent of theta. So we are going to let this be theta. Okay, so we have theta equals the arc sine of 2 over x. So what does that mean? That means that the sine of theta is equal to 2 over x. And you remember, if we have so katoa, this is going to be, I kind of wrote that a little close to that. So this is going to be the opposite over the hypotenuse, okay? So we could just draw a little triangle here, and we could have our theta, we could have 2, and we need x to be that hypotenuse, okay? So, oops, that x, okay? That's our typical. So we better call this a, since we already have an x. So we know that a squared plus 2 squared is going to be x squared, okay? So we have a squared is x squared minus 4, and a is root x squared minus 4. So now taking that triangle, see if I can kind of move it over here, and taking that triangle, we can now write that the tangent of theta, remember that's opposite over adjacent, will be 2 over a. And that's just equal to 2 over root x squared minus 4. Okay, and that will be our answer. Okay, now let's apply an inverse trig function to a word problem, okay, an application problem. The Eiffel Tower is 1,063 feet tall. So I'm going to I haven't even continued to read this, but I'm just going to put that on there, okay? Looks like I'm going to make a triangle. A measurement is taken of the length of the shadow of the tower. So that measurement is found to be 310. So we always have to have some sort of angle here, okay? So this angle of elevation is going to be theta, okay? And so they said that the length of the shadow is 310 feet. So they want us to approximate the angle of elevation of the sun to the nearest tenth of a degree. So what could you say? We have the tangent of theta, remember, opposite over adjacent would be 1063 divided by 310. So what do? We now can write theta equals the tan inverse of 1063 divided by 310. And if you put that in your calculator, you will get 73.7 degrees. And we just needed one decimal place, and we wanted degrees. Okay, let's take a look real quick at the inverse, secant, cosecant, and cotan functions, okay? Now, we do have this restriction on the secant, and as you can see, we have from 0 to pi over 2 or pi over 2 to pi, and these are strict inequalities, okay? At pi over 2, okay, strict. So taking a look at this, now we have the inverse function written there, and likewise with the cosecant, negative pi over 2 to 0 and 0 to pi over 2. And let's look at the cotangent. We will be between 0 and pi for the cotangent of x. We have these restrictions again so that that inverse function exists. Let's evaluate a few of these. We have the secant inverse of 2. We'll work these the same way. That's equal to y. So we can now say that the secant of y is equal to 2. Now, if we have the secant, which is where the cosine is going to be, okay, so we can have, for the secant, we can give an angle in either quadrant 1 or quadrant 2. And taking a look at this secant, if the secant of y is equal to 2, then the then the cosine of y would have to equal 1/2. And of course, we know that y would have to equal pi over 3. So we would choose, of course, this first quadrant. Okay, let's go ahead. The cotan inverse of negative root 3 is equal to y. Okay, so we have the cotangent, and we can give an answer anywhere in between 0 and pi. And so we have that the cotangent of y is equal to the opposite of root 3. So now we know that we will have to choose quadrant 2 since that cotangent is negative in quadrant 2. So we would have to choose 5 pi over 6 since the cotangent of pi over 6 is root 3. We know that the cotangent of 5 pi over 6 is equal to the opposite of root 3. So y is equal to 5 pi over 6. Okay, let's look at number 19, the cosecant inverse of the opposite of 2 root 3 over 3. We'll let that equal y. So the cosecant of y is the opposite of 2 root 3 over 3. Now, we have that the cosecant, we must provide an angle for the cosecant that is between negative pi over 2 and 0, and then 0 to pi over 2. So it would have to be in this location or this location. And as you can see, since it's negative, we will need to provide an angle in quadrant 4. So we will have that y must be equal to the opposite of pi over 3. And keep in mind that the cosecant of pi over 3 is equal to 2 root 3 over 3. Okay? And we can just note that, okay? I could even just put a little star by these. Okay? And I could have put this that the cosine of pi over 3 is equal to a half here. Okay. Okay, in number 20, they've asked us to use a calculator to approximate the cosecant inverse of 8/5. And they would like this in radians and rounded to 4 decimal places. Now keep in mind that we do not have a key on our calculator for the cosecant inverse. But we can use trig properties to come up with this. So they've asked for the cosecant inverse of 8/5. Well, that's the same thing as asking for the sine inverse of 5/8. And that's going to be approximately equal to 0.6751. And that concludes this section.